For problem number 46, we want to determine whether the series is convergent or divergent by expressing it as a telescoping sum. So for 46, we have the sum of cosine of 1 over n squared minus cosine of 1 over n plus 1 squared. So let's expand this all the way up to n is equal to 3 just to see what it does. So our first index is n is equal to 1, so we're going to have we're going to have cosine of 1 over 1 squared, so that's just going to be cosine of 1, minus cosine of 1 over 1 plus 1 squared, so that's going to be 2 squared, so it's going to be minus cosine of 1/4, and then plus cosine of, now for n is equal to 2, we're going to have cosine of 1 over 2 squared, so cosine of 1 over 4, so plus cosine of 1 over 4, and then minus cosine of 1 over 2 plus 1 squared, so cosine of 3 squared, which is minus cosine of 1 over 9. And then let's do lastly for n is equal to 3, so plus cosine of 1 over 3 squared, that's 1 over 9, so cosine of 1 over 9, and then minus cosine of 1 over 3 plus 1 squared, so 1 over 4 squared, which is plus cosine of 1 over 16. So if we look at the sum, the pattern here is very clear, where this cosine of 1/4 minus plus, these are going to cancel out, and then we have minus cosine of 1 over 9 plus cosine of 1 over 9, so these are going to cancel out. And then what we're left here, so remember that we did this for n is equal to 3. So we're going to be left with cosine of 1, because no term after that is going to cancel it. So that's going to be cosine of 1, and then plus that should be a minus here that I wrote accidentally. So minus cosine of 1 over 16, and 16 is this n plus 1 squared term, right? Which we weren't able to remove because it would be the next 1 over n squared that would cancel it out. So here we have cosine of 1 minus cosine of 1 over n plus 1 squared, because we did this for n is equal to 3. So 3 plus 1 is 4, 4 squared is 16, so that matches up. So we can see that our entire sum can just be boiled to this, where we're only going to have the first term and then minus cosine of 1 over the last term plus 1 squared. So once we're here, we can rewrite this as just cosine of 1 minus cosine of 1 over n plus 1 squared. So that's the entire sum, and once we're here, we're ready to take our sum. Now, n is going to be infinity, so we can't just plug in infinity. The way that we do it is with the limit. So to find this, we have to take the limit as n approaches infinity of cosine of 1 minus cosine of 1 over n plus 1 squared. And if we do this, that's going to be the limit as n approaches infinity of cosine 1, that's just cosine of 1, minus, this is going to be cosine of, if we take the limit infinity here, it's going to be 1 divided by infinity squared, which is 0. So minus cosine of 0. And that is it. This is the result of our telescoping sum. So just to kind of give a quick recap of what we did, we took this sum here and we expanded it up to n is equal to 3. You could have done more, could have done less, but if you had done it, you would have seen that the pattern would be where cosine of 1, which is the first term, nothing's going to cancel out, and then everything else is going to cancel out except the very last term. So that's what we keep here, and then we take the sum by just taking the limit as n approaches infinity, and we find that this is cosine of 1 minus cosine of 0, which is actually just cosine of 1 minus cosine of 0 is just 1. So that is it for problem 46.